Good morning, students. The last class we started for solving the continuous time Fourier transform of a triangular pulse shown in this figure. Okay. So I suggested either you remember the formula of this del function, or simply you can find the expression for this del function between minus tau by 2 to 0 and 0 to tau by 2. Separately you solve it and you will get these equations. Okay. Then apply in the formula, do the integration carefully, UV formula, and substitute your limit step by step. So up to this step, we have discussed in the previous classes. So from that, I just substituted the integration limit and I have solved. And finally, I converted my result in the form of sinc function. Okay, sine theta by theta, sinc function. So in this example, it comes in the form of sine square theta by the theta square format. So my result is tau by 2 sinc function square omega tau by 4. Okay. So rectangular pulse, triangular pulse, and the previous problems, u of t and signum function, these are all some standard problems in Fourier transform. So we should remember the formula of what is the ft of signum function, what is the ft of u of t, what is the Fourier transform of uh, rectangular pulse, triangular pulse, and all. Okay, because later we will be solving some problems using properties of Fourier transform. Okay, so just go through these steps. I don't have time, so we will move on to next topic. Right. In general, exponential Fourier series, and continuous time Fourier transform, Laplace transform, then discrete time Fourier transform, Z transform. So all these mathematical tool, uh, basically we will solve some problems using formula. Problems using the formula Fourier series CTFT, direct problems. And then next properties of Fourier series CTFT, LT, DTFT is a transform. Then problems using problems using properties. And finally, for CTFT, LT, DTFT is a transform. Then solving LTE system. Solving LTE system described by the differential equation or difference equation. Differential equation for continuous time mathematical tool. A difference equation will solve by using DTFT as a transform. So these are the pattern actually. But here the properties of all the transformation, I need more number of lectures to cover property name and proof of each and every properties. Okay, so I will give you the material for the proof of all the properties, the handwritten material, and I'll be more focusing about what properties is and how to solve the problem using properties only, because of the insufficient time. Okay. Please remember these properties are very important. Exponential Fourier series also the properties are available, and the most of the time you don't have the problems using properties of exponential Fourier series. But CTFT, LT, DTFT is a transform. More problems are there. A basic problem also there, and the properties using properties we will be solving some problems. And finally, system differential equations. So this is the format. Okay. So now we started the CTFT and we completed the basic problems as of now. Now I'll write down or I'll list out the properties of Fourier transform one by one. and we will solve the problems using properties of Fourier transform. Properties of continuous time Fourier transform. In short form, it is represented as CTFT. Okay. First property. Before that, write down the formula. X of t is the representation of a continuous time segment. If we find the Fourier transform of the signal, we will get x of j omega. If y of t, Fourier transform y of j omega, and so on. Okay. So please remember this. If you take inverse Fourier transform of x of j omega, you will get x of t. That's why we are indicating this arrow mark in both sides. X of t to x of j omega possible in forward direction. From x of j omega to x of t possible in the reverse direction if we apply inverse Fourier transform. So property number 1, linearity property. Linearity property. So what linearity property says? Fourier transform of x1 of t. Let us assume Fourier transform of x1 of t represented by x1 of j omega. And Fourier transform of x2 of t represented by x2 of j omega. Then Fourier transform of ax1 of t plus bx2 of t. We find the Fourier transform of ax1 of t plus bx1 of t. The result should be equal to a1 x1 of j omega. The property we already studied in unit 1, linearity system. The system should satisfy both additive property and homogeneous property, called as linear system. A1 x1 of j, sorry, yeah, A1 x1 of j omega, AB I written here. So A x1 of j omega plus B x2 of j. Okay. So this property called as linearity properties of Fourier transform. X1 x1 of j omega, x2 x2 of j omega. Now if we find Fourier transform of ax1 plus bx2, the result should be equal to ax1 of j omega plus bx2 of j omega. It's a linearity property there. Now we will solve some problem using this linearity property. Property and then followed by problems. It is better for you. So many problems are available. I'll try to cover one problem from each type model. Omega versus x of j omega spectrum given. At 0, the magnitude is 2. At omega naught, the magnitude is 0.5. Okay. At 3 omega naught, the magnitude is 2. At minus omega naught, the magnitude is 0.5. Minus 3 omega naught, the magnitude is 2. Okay. So this is the signal given now. Determine the inverse Fourier transform of the spectrum. Determine the inverse Fourier transform. Omega x of j omega. X of j omega meaning ft of x of t. So x of j omega given not in the mathematical expression, in the spectrum format in for ft of x of t given. Determine the inverse Fourier transform of the spectrum. First, write down the mathematical expression for this signal, because we already studied in Unit 1 how to represent a del function. T versus del of t at t equal to 0, magnitude 1. T minus 2, say for example, at t equal to 2, the magnitude is 1. Correct? Similarly, how to represent del of t plus 2? Del of t plus 2, 0, minus 1, minus 2. At minus 2, the magnitude is 1. Okay. So these are all some basic concepts we know already. Here the variable is t. So in this example, the variable is omega. That's it. So it is possible to write the mathematical expression from the given spectrum. The spectrum contains only the impulse component, shifted version of the impulse component. First, write down the mathematical expression, that is x of j omega equal to, at omega 0, magnitude 2. At omega 0, magnitude 2. So how to write? 2 del of omega. Correct? See, here it is del of t, here it is del of omega. Here magnitude 1, here magnitude 2. So 2 into del of omega. Next, magnitude 0.5. 0.5, it is shifted omega naught time right side. So 0.5 del of omega minus omega. Right? Next, magnitude 2. 2 into del of omega minus 3 omega naught. So mathematical expression for this component and this component and this component completed. So now reverse side. 0.5 magnitude. 0.5. If the signal shifted left side, how to do it? Del of t plus 2. Similarly, so 0.5 0.5 del of omega plus omega naught. 0.5 del of omega plus omega naught. For this component, magnitude 0.5 del of omega plus omega naught, plus this component 2, magnitude 2 del of omega plus 3 omega naught. Okay. So instead of giving this mathematical expression of x of j omega directly, the spectrum diagram is given. From the spectrum diagram, we have written the x of j omega expression. Right? Now apply the Fourier inverse Fourier transform. Inverse Fourier transform. So before that, so inverse Fourier transform of x of j omega, that is equal to inverse Fourier transform of this component plus inverse Fourier transform of this component, inverse Fourier transform of this one, and so on. That is the linearity property says. Okay. So find the individual inverse Fourier transform and combine together and finally write down your x of t. So inverse Fourier transform of x of j omega equal to x of t. Right? Now find out inverse Fourier transform of each and every component. So already we solved some problem. Do you remember? The beginning of the Fourier transform formula, a Fourier transform, we have solved some fundamental formula, that is starting from here. X of j omega del of omega. See? Inverse Fourier transform of del of omega equal to 1 by 2 pi. Right? Inverse Fourier transform of del of omega 1 by 2 pi. Next, Inverse Fourier transform of 2 pi del of omega minus omega naught e power j omega naught. Inverse Fourier transform of 2 pi del of omega plus omega naught e power minus j omega naught. Okay, so these are the formula already we have derived. So with the help of those formula, now find out the inverse Fourier transform of each and every component. So inverse Fourier transform of del of omega, this function, 1 divided by 2 pi. Okay, for del of omega only. Next, inverse Fourier transform of del of omega minus omega naught. The result is 1 divided by 2 pi e power j omega naught t. Next, inverse Fourier transform of, what are the other component available? Del of omega plus omega naught available. The result is 1 divided by 2 pi e power minus j omega naught. Okay. So similarly, inverse Fourier transform of del of omega plus 3 omega naught equal to 1 divided by 2 pi e power minus j3 omega naught. So last component, del of omega minus 3 omega naught. The result is 1 divided by 2 pi e power plus j 3 omega naught. Okay, from where this formula? This formula we have derived already. So no need to solve again. So just write down the answer only. Inverse Fourier transform of del of omega 1 by 2 pi. Now substitute all this value and write down your inverse Fourier transform of x of j omega, that is x of t. Now x of t equal to, this is a constant del of omega plus 3 omega naught. What is inverse Fourier transform? 1 by 2 pi e power minus j 3 omega naught. So already that magnitude 2 is available. Let it be 2 1 by 2 pi e power minus j 3 omega naught t. Okay. Next, 0.5 del of omega plus omega naught. 0.5 is a constant. So plus 0.5. Okay. Del of omega plus omega naught t. 1 divided by 2 pi. 1 divided by 2 pi e power minus j omega naught t. This point. What is next component? 2 del of omega. So 2 del of omega inverse Fourier transform 1 by 2 pi. Next component 0.5 del of omega minus omega naught. 0.5 del of omega minus omega naught. So del of omega minus omega naught inverse Fourier transform 1 by 2 pi e power j omega t. So 0.5 1 divided by 2 pi e power j omega t. Okay. The last one, del of omega minus 3 omega naught. So magnitude 2. So 1 divided by 2 pi e power j3 omega naught. Okay. So linearity property we have written in the form of time domain to frequency domain. Same principle applicable for inverse Fourier transform also. Okay. The x of j omega given. If you find inverse Fourier transform of this x of j omega, that is equal to inverse Fourier transform of individual component and then add it together. That's what we are doing now. So first we have written inverse Fourier transform of each and every component. Now write in the expressions. Okay. So this is your final answer. So cancel this 2. So okay. Then write down your final answer. If possible, simplify. X of t, this is 1 by pi. This term is 1 by pi. Okay. Next, e power j omega t plus e power minus j omega t. Okay. E power j omega t plus e power minus j omega t equal to 2 cos omega t. Okay. E power j omega t minus e power minus j omega t 2j sin omega t. So using this formula, we may combine this term e power minus j omega t, e power plus j omega t. Okay, and write down your result. So already 0.5 divided by 2 pi is a common term. Now if we combine together 2 cos omega naught t, these two will be cancelled. Next, 1 divided by pi is the common, e power j3 plus e power minus j3. So 2 cos 3 omega naught t. Okay. So for the given x of j omega, the inverse Fourier transform result is 1 divided by pi plus 0.5 divided by pi cos omega naught t plus 1 divided by pi 2 divided by pi cos 3 omega naught t. So this is the result. X of j omega given in the form of pictorial representation. Then we have written the mathematical expression for that using the del function, shifted version of the del function format. And the student should remember the formula of del of omega plus omega naught and so on. Then it is very simple. Directly substitute and solve it. You will get the result. Okay. So this is one example for linearity property. Second example, x of t equal to 5 sine square 3t. By looking at this expression in your semester exam, you don't think that we have not solved this problem. We have only the standard problems like e power minus at ut and so on. So if these kind of problems given, we cannot apply the Fourier transform directly. That is integration minus infinite to infinite x of t e power minus j omega t dt. Now you have to apply the linearity property. How to apply the linearity property? First expand this sine square theta. So sine square theta equal to 1 minus cos 2 t theta by 2. 1 minus cos 2 theta by 2. So 1 minus cos 60. 1 minus cos 60 by 2. I'm taking the 2 outside. Okay. Now Fourier transform of x of t, x of j omega, that is equal to 5 by 2 of Fourier transform of 1 minus cos 60. So as per the linearity property, Fourier transform of 1 minus Fourier transform of cos 60. Okay. Substitute here, your answer is 4. Fourier transform of 1. You remember what is the result for Fourier transform of 1? In the beginning of Fourier transform, we have solved. Fourier transform of 1 result is 2 pi del of omega. Okay. And Fourier transform of cos omega naught t. Fourier transform of cos omega naught t. The result is pi del of omega plus omega naught plus pi del of omega minus omega. Now directly substitute here. So pi del of minus pi del of omega plus 6 plus del of omega minus 6. That's it. This is your result. Okay. So Fourier transform of 5 sine square 3t. First step, expand sine square theta equal to 1 minus cos 2 theta by 2. And then remember the formula of Fourier transform. Here we have solved some problem previously. Del of omega. Fourier transform of 1 is 2 pi del of omega. Okay. Fourier transform of cos omega naught t. The result is pi del of omega minus omega naught plus omega del of omega plus omega. Similarly, sine omega naught t also we have solved. So students should remember this formula and then directly write that formula here. Okay. Next, we move on to another property. Property number 2. Time shifting property. What is time shifting property? X of t, take Fourier transform, result is x of j omega. Then x of t minus t naught. If the input signal, that is x of t, if that particular continuous time signal x of t delayed by t naught amount of time. Now if you apply the Fourier transform, this would be equal to e power minus j omega t naught into x of j omega. Okay, so this is the time shifting property. So in your examination, you may expect, say, any 4 properties of continuous time Fourier transform and prove it. Or they will specify, write down the time shifting properties of Fourier transform and prove it. Okay, so all the proof of this property I will give you as a written notes separately. It's a very simple one. Just we need to substitute x of t minus t naught in the formula and we solve it. Okay. So x of t, x of j omega. X of t minus t naught, the result should be equal to, the result is e power minus j omega t naught into x of j omega. Some example problems we will discuss. Using the Fourier transform property, they won't specify the property name and all. Using Fourier transform property, find Fourier transform of the signal given below. Okay. Property name and all they will not specify. You have to check the appropriate property which will be used to solve this particular problem. The given problem, t versus x of t or x1 of t given us like this. 0 tau. Magnitude is 1. Okay. Find the Fourier transform of this signal. So in the previous class, we have solved Fourier transform of two standard functions. One is rectangular function. Remember, rectangular function from minus tau by 2 to tau by 2 magnitude 1. What is the result? Tau sinc function omega tau by 2. Similarly, triangular pulse minus tau by 2 to tau by 2. The result is tau by 2 sinc square of omega tau by 4. Okay. So this given rectangular pulse, standard rectangular pulse Fourier transform result we have solved already. We know that that is your pi of t pi tau in general format minus tau by 2 to tau minus tau by 2 to plus tau by 2. The magnitude is 1. Okay. So for this signal, we know the answer. So can we rewrite this particular signal in terms of standard rectangular pulse? Any idea? Minus tau by 2 to tau by 2. That meaning what is the total time duration? What is the total time duration of this standard function? Please reply.
Tau, sir.
Tau.
Tau,
So
tau.
now look at this signal. What is the total time? Tau. So how much time the signal shifted right side now?
Tau by 2.
Tau by 2. Okay, only tau by 2, right? So from here to only tau by 2, the signal is shifted. So we can rewrite this signal if x of t equal to pi of t by tau, then x1 of t, that is in the given problem, should be equal to x of t minus tau by 2. Right? So now apply the shifting property, time shifting property. So Fourier transform of x of t, that is pi del of t. The result is tau sinc pulse omega tau by 2. Please remember the formulas of all the standard functions. Okay. Now the Fourier transform of x of t minus tau by 2. So as per the Fourier time shifting property, x of t, x of j omega, x of t minus t naught delayed by t naught, then e power minus j omega t naught. If plus t naught meaning here also you have to put plus. Okay. So e power minus j omega t naught. E power minus j omega t naught. T naught is tau by 2 into tau sinc pulse omega tau by 2. So this is the answer for the given signal. Okay. Right. Property number 3, linearity, time shifting. Next, time reversal property. time reversal property. So this property says that if x of t Fourier transform is x of j omega, then x of minus t, the Fourier transform result is equal to x of minus j omega. X of t, x of j omega, x of minus t result is x of minus j omega. One example, x of t equal to e power at dot u of minus t. Find Fourier transform of this. Okay. X of t equal to e power at u of minus t. We know that the formula for e power minus at u of t. This is standard formula we have derived in the beginning of the Fourier transform classes. E power minus at result is 1 divided by a plus j omega. Okay. Now we have to find out Fourier transform of e power at u of minus t. That is, if we consider the signal is x1 of t, Fourier transform of x of t, Fourier transform of x of t, that is x of t equal to e power minus at ut. The result is 1 divided by a plus j omega. Now Fourier transform of x of minus t. Correct? In this equation, if you substitute t by minus t, you will get e power at u of t. So what the property says? Wherever j omega is there, replace all j omega by minus j omega. Minus. In this example, only one j omega term is there. So that j omega replaced by minus j omega. So remember, this is another formula. E power minus at ut 1 divided by a plus j omega. This formula already we have derived. To find x1 of t equal to e power at u of minus t Fourier transform, apply the time reversal property. Fourth one, frequency shifting property. Time shifting property already we discussed. Now frequency shifting property. So what this property says, x of t Fourier transform x of j omega. Suppose x of t multiplied with e power j omega naught t. Now if we apply the Fourier transform for this complete signal, x of t e power j omega t, the result is equal to x of j omega replaced by omega minus omega naught. Similarly, x of t e power minus j omega naught t, the Fourier transform is equal to x of j omega plus omega. So this property called as frequency shifting property. That is the frequency shifting by omega naught amount time. If here plus meaning here it is minus. Here minus meaning here it is plus. So this property called as frequency shifting property. Time shifting meaning x of t minus t naught. Frequency shifting meaning x of t multiplied with e power component. So based on this property, one problem we will discuss. Example, find Fourier transform of e power j omega naught t u of t using Fourier transform properties. e power j omega naught t u of t using Fourier transform property. Similarly, another problem. Okay, we'll complete this. Yes, almost time 9:43 now. Right. So e power j omega naught t u of t. Let assume u of t is our x of t. What is Fourier transform of u of t? We have solved already. The result is 1 by j omega plus pi del of omega. Fourier transform of u of t. The previous classes we have solved. We have written the u of t in terms of signum function plus some dc value, and finally we obtain the result 1 by j omega plus pi del of omega. Now e power j omega naught t into u of t. Fourier transform of e power j omega naught into u of t. So what is the frequency shifting properties is, when the x of t is multiplied with e power j omega naught t, then you are in the resultant x of j omega, wherever j omega is there, the j omega replaced by j omega minus omega naught, or e power minus j omega naught t multiplied with x of t, in your resultant x of j omega, wherever j omega term is there, that should be replaced by j omega plus omega naught. So in this example, let assume x of j omega, that is Fourier transform of u of t, is 1 by j omega plus pi of dx, pi del of dx. So e power j now, wherever j omega term is there, so omega term particularly, not j omega, wherever the omega term is there, that omega replaced by, here it is plus, so omega minus omega plus pi del of omega minus. So this is the result. E power j omega naught t, e power minus j omega naught t multiplied with some signal. If we know the Fourier transform of that particular signal, we can use this property directly. Okay. One more problem under this category. Find the Fourier transform of cos omega naught t dot u of t. Cos omega naught t dot u of t using properties. They won't mention what properties. Okay. So cos omega naught t, we know e power j omega naught t plus e power minus j omega naught t divided by 2 into u of t. So 1 by 2 e power j omega naught t dot u of t, right? Plus 1 by 2 e power minus j omega naught dot u of t. Okay. Similarly, like previous problem. So in the previous problem, e power j omega naught t ut available. Now e power j omega t ut, e power minus j omega t ut. Okay. Now apply the frequency shifting property and write down your answer. Okay. So shall I write directly? Because in the previous problem we discussed already how to solve it. So the result is 1 by 2 1 divided by j omega minus omega naught plus pi del of omega minus omega naught for the first. Second, 1 divided by j omega plus omega naught plus pi del of omega plus omega. So this is the result. Okay, because For this part, just now we have solved e power j omega naught t ut. E power j omega naught t ut. Result is 1 by j omega minus omega naught plus pi del of omega. If the minus is available here, then here plus plus. So I have directly written this formula because just now we solved the problem. Thank you all. And